Welcome back to Part B. We are picking up right where Part A ended with Section B. Let's continue. Section B. Here you choose any 3 questions. We'll work through all 5 so you can pick your strongest. Question 16. Part A is compound interest. Savison invests 80,000 francs for 3 years at 5% per year, compounded. Find the amount. Compound interest is like a snowball rolling downhill. Each year it grows on what it has already gathered, so you earn interest on the interest, not just on the original money. So the amount equals the principal times 1 plus the rate, raised to the number of years. That is 80,000 times 1.05 cubed. 1.05 cubed is 1.157625. Multiplying gives 92,610 francs. Question 16, Part B. This is a proportion problem. 40 people eat 200 kilograms of rice in 30 days. How many days would it take 30 people to eat 500 kilograms? The key is to find how much one person eats in one day. That rate is 200 divided by 40 people times 30 days, which is 1/6 of a kilogram per person each day. 30 people then eat 30 times 1/6. That is 5 kilograms every day. To finish 500 kilograms, divide 500 by 5. The answer is 100 days. Question 17. Part A. We are told that the cubic p of x equals x cubed minus x squared minus 14x plus 24, and that x minus 2 is a factor. When a cubic is divided by one of its factors, the result is the quadratic that carries the other 2 factors. So we divide p of x by x minus 2. The quotient is x squared plus x minus 12. Comparing with a x squared plus bx plus c, we read off a equals 1, b equals 1, and c equals minus 12. Question 17, parts B and C. Now we factorize the quadratic and solve. The concept: once the cubic is a product of brackets, we set each bracket to 0 to find the roots. We need 2 numbers that multiply to minus 12 and add to 1. Those are minus 3 and 4, so x squared plus x minus 12 factors as x minus 3 times x plus 4. The full cubic is x minus 2 times x minus 3 times x plus 4. Setting p of x equal to 0, each bracket gives a solution. X equals 2, x equals 3, and x equals minus 4. Question 18. The vectors are u equals 5, x minus 1, and v equals 3, 3 minus x. Part A, perpendicular. 2 vectors are perpendicular when their dot product is 0. The dot product is 5 times 3 plus x minus 1 times 3 minus x. That gives 15 minus x squared plus 4x minus 3, which tidies to x squared minus 4x minus 12 equals 0. Factoring, x minus 6 times x plus 2 equals 0, so x is 6 or minus 2. Part B, parallel. 2 vectors are parallel when the cross term is 0. That is 5 times 3 minus x minus 3 times x minus 1 equals 0, which gives x equals 9 over 4. Question 18, Part C. Now, for which value of x are the 2 vectors equal? 2 vectors are equal only when every matching component is equal. Compare the first components. 5 would have to equal 3. But 5 is never equal to 3, no matter what x is. So the second components do not even matter. There is no value of x for which the vectors are equal. Question 19. Part A. In trapezium, ABCD, the segment FG is parallel to AB, and its length is 2x squared minus 5x centimeters. Because FG is a real length, it must be greater than 0. So 2x squared minus 5x is greater than 0, which factors as x times 2x minus 5 greater than 0. This holds when x is less than 0 or when x is greater than 2.5. Since a physical length is positive, we take x greater than 2.5. Read this exact condition against the marked figure on the exam paper. Question 19, Part B. The trapezium has area 60 square centimeters and height 6 centimeters, and we want the mid-segment EF. Two ideas here. First, the area of a trapezium is 1/2 the sum of the two parallel sides times the height. Second, the mid-segment joining the midpoints of the slanted sides equals the average of those two parallel sides. So 60 equals 1/2 times the sum times 6, which gives the sum of the parallel sides as 20. The mid-segment is half of 20, that is 10 centimeters. Question 20. The triangle has vertices A at 0, 4, B at the origin, and C at 4, 4. Every transformation has a coordinate rule that we apply to each vertex. Part B is central symmetry about the origin, where x, y maps to minus x minus y. So A becomes 0 minus 4, B stays at the origin, and C becomes minus 4 minus 4. Part C is a reflection in the vertical line x equals 5, where x, y maps to 10 minus x, y. So A goes to 10, 4, B to 10, 0, and C to 6, 4. Question 20, Part D. A translation T carries A at 0, 4 to A triple prime at minus 3, 6. The idea is to read the translation vector off one known image, then apply the same shift to every other point. Subtracting A from its image, T is minus 3 minus 0, and 6 minus 4, that is minus 3, 2. Now apply it. B at the origin shifts to minus 3, 2, and C at 4, 4 shifts to 1, 6. A few reminders before your exam. Always show you're working because marks reward the steps, not only the final answer. When quantities look different, rewrite them in a common base or a common form before you compare. Check that each answer makes sense for what was asked. And in section B, choose the 3 questions you can complete fully. Wonderful work. You've now seen a clear method for every question on this paper. Practice them in your own words, then try another past paper to build speed. With Inzira, you can learn, practice, and master. See you in the next one.